Hello, welcome back. So we've got 3 questions just to finish off, starting with question 18. So question 18, the diagram shows a triangular field PQR, which is used to grow organic carrots. We've got the lengths and the angle there. In recent years, an average of 2.5 kilograms of carrots has been harvested from each square meter of the field. Okay, so we need to work out this. The problem we've got is we don't have the height of this triangle, but we can use a half AB sin C to work that out, which is going to be a half times by 80 times by 100 times by sin 30. So we need to know what sin 30 is worth. Here is an equilateral triangle. I'm going to split that down the middle so that we've got a base of 1. This angle is 60, this is 30, and that's my perpendicular. So let me just redraw that. 60, 30, 2, 1, and then this height here is the result of. I need to show you all of these steps. So 1 squared plus the height squared equals 2 squared. The height squared will equal 4 minus 1. So the height is the square root of 3, like so. And then from here we can work it out. So for sin, we need the opposite, which is here. We need, and I need SOH. Ooh, I need the hypotenuse. Silly. Oh, can you tell it is such a long day? So for sin, it's the opposite over the hypotenuse, and that means it's 1 over 2. And that means that that's our value we're taking in here. So that's a half. So we need to just rewrite this. A half times by 80 times by 100 times by another half. So I'm going to half the 80 and then half it again to make 200, which gives me 20 times by 100, which is 2,000. And then that's going to be multiplied by 2.5 for our 2.5 kilograms per square meter. And that gives us 5,000 kilograms. Okay, sorry about that silly mistake. I'm so tired. I'm just bumbly. Right, why might the answer to part A be unreliable? So the conditions for growing might not be good enough. So it might be too wet, might be too much sun. So, okay, question 19. Complete the square. So we halve that 10, giving us a 5, and then we subtract the square of 5, because that's what will come out of that squared bracket, and then we have the plus 22. X take away 5 all squared, and then that's going to be take away 3, and that's our final answer. So we've completed the square there. Right, so I know this graph is going to cross at 0.22. I probably want to put that a bit higher. And then our next bit, we know that our minimum point is going to be at 5 and then negative 3. So that's going to be somewhere there. That's our minimum point. So up like that. 5, negative 3, and then 0.22 for that y-intercept. And we don't have to do the solutions because it doesn't ask us for it. So we can just move on. Okay, last question. So ABCD is a trapezium. The perimeter of the trapezium is 56. I've got a little bit of red there. The ratio AD, AB, DC, BC. So AD is 5, AB 12, DC is 6, and then BC is 5. That adds up to 12, 18, 28. The perimeter is 56, so actually I need to double all of these lengths. So I'm just going to rub these out and put the proper lengths in. So 12, 24, 10, and then another 10. Right, I need to know a height here somewhere. So let's work this out. So this is isosceles because we've got the 10 and the 10. Therefore, that means that we've got between here and here 12. That's a 6, and that's a 6. And then I can use Pythagoras' theorem to work out that height. So the height squared plus 6 squared will equal 10 squared. The height squared plus 36 will equal 100. The height squared is 64, so the height is going to be 8. Right, work out the area of this trapezium. Last thing we need to do, so it's a half a plus b times by the height. Okay, so a half times by 36 times by 8. 36 times by 4. 2 lots of 72, 144. Okay, and then that gives us our final answer. Okay, that's the paper over with. Look out for paper 6. That's going to be coming out soon. Good luck with your revision, and I wish you every bit of luck in your mocks or in the summer. Bye-bye.